Late last year, I released my video part 1 going over building my new Proxmox server, and since then, oh boy have I learned quite a bit, partially with the help of you guys, committing and putting issues on the GitHub to improve and optimize that setup. So what we're going to do in this video is basically remake that with all the changes and improvements since recording that video. So this is going to be my new part 1 Proxmox full setup guide. So in this video, we are going to be going over the full Proxmox install, go over some post-install steps that I usually do, set up my ZFS storage pools, such as the flash pool in my tank, which will hold a whole bunch of data for us. And of course, we're going to create our very first Proxmox container, assign some storage to it, and create some network shares so we can access that storage anywhere on our home network. Now, of course, the very first consideration when doing this is the actual hardware that you are going to be using. You can install Proxmox on just about anything, whether that be something like a mini PC, a NAS unit that supports installing third-party operating systems, or even an older desktop computer that you plan on repurposing to build as your home server. There are a ton of variables when it comes to picking the hardware that you are going to use. Again, you can use just about anything. My general recommendation is a CPU that at least has like 4 cores minimum. It depends on how many services you plan on running. If you're running AMD, I recommend any like Ryzen 3000 series or higher. Bare minimum, if you're using Intel, I recommend you get a CPU that supports the Intel QuickSync and hardware transcoding for media in the future. That's going to come very handy. If you're running an AMD desktop like this, I would also recommend throwing in a NVIDIA GPU that also supports hardware transcoding. Down below, I'll leave more detailed information on kind of the specs I recommend. And then when it comes to storage, this will vary wildly depend on what you could actually put in your hardware. Generally, I recommend using a NVMe SSD as your boot drive. If you're not going to be able to put more NVMe drives in your system, try to go with a larger one, 512 gig, terabyte preferred, or higher if your budget allows it. And for bulk file storage, such as your movies, TV shows, image backups, things like that, you can get some pretty affordable 4 terabyte drives. I recommend at least 2 of them, so then you can mirror them. So if one fails, you could swap it out and you won't lose any data. Again, it doesn't really matter what you use, but for this video, I am going to be demoing this with a ZimaCube. That thing is pretty nice. It supports up to 6 hard drives and 5 NVMe flash drives. So for me in this video, I'm going to have 6 4 terabyte drives in the thing, and I'm going to have 3 NVMe flash drives. One is going to be what I'm going to use as the boot drive. I'm really not going to be storing too much on it, so that's going to be more than enough because I'm going to install 2 additional 1 terabyte NVMe drives, and those will be mirrored just in case if one fails, I can switch it out and life is good. And I'll talk a little bit more about that once we get into setting up our storage. I'll also note doing this on a desktop, old desktop computer is probably the most flexible because you could get PCIe cards to help you expand your actual hard drive connectivity or your the amount of NVMe SSDs you could have in your system, which is very nice. So you have your hardware, you're ready to install Proxmox. The first thing is get a USB drive just like this and flash the Proxmox installer onto it. First, you go ahead, go to their website, download the installer, and then depending on whatever system you're on, you're going to want to flash that ISO image to the USB. If you're on Windows, I recommend you use Rufus. If you're on Mac OS, you can use a Balena Etcher. And if you're on Linux, I recommend using the GNOME disk utility, selecting it, and just restoring the ISO image directly to it. And when it is complete, you can plug this right into the system you plan on installing Proxmox onto, and go into your BIOS and boot to the USB. Depending on your hardware and motherboard, you may need to change some settings in the BIOS, such as disabling secure boot so you can run operating systems like this on your system, and potentially enabling virtualization, because that's really what Proxmox is a virtualization platform. And then when you boot up the installer for the first time, you're going to want to select Install Proxmox with the graphical installer, and then you will have a user license agreement. Go ahead and skim through it if you'd like to and agree to it. And from here, we have the target hard disk. If you have multiple drives in your system, you're going to want to make sure you select the correct one. I am putting this on the one that says 238 gigs, the smallest one on my system. When installing, I've yet to install the additional NVMEs I'm going to put on here, so they're not showing up yet. So you click next, you're going to want to select your location and time zone, and then create your administration password and email address. So pick a strong and secure password, and the email address can be just about anything. I put in my business address for now. And then we have interface management. Before you start the installer, you're going to want to make sure you have your Ethernet plugged into it so then it can detect what your active interface is going to be. And you can see that with a little green spot there. Then you're going to want to pick your host name. This is kind of important because this is what it's going to show up as on your network and when you actually log in. PVE.LAN is the default, and you could keep that if you want to. For this one, I'm going PVE-guide.local, PVE standing for Proxmox Virtual Environment, and your host name, of course, is whatever appears before the .local. You could change your IP address here if you'd like it to be something specific. For gateway and DNS server, in most cases, you can probably leave that as is. And then you'll get a little summary of everything that you're doing. Skim through it, make sure everything's right, and then go ahead and click install, and it will automatically reboot after the installation. When the installation is complete, it will reboot, and then it will look something like this. You can log in directly into the shell here. You don't need to do that because we're going to go to the web interface, but there's a little reminder up there of what our IP address is. For us, it's going to be 10.0.0.32 and the port 8006. So now that we have our IP address, we're just going to head back to our system here to the desktop. And you can see I already navigated to it, ending in 32 and 8006 right here. And then we just log in with root and then the password that we set up during the installation process. Now from here, you're in Proxmox. You technically set up your very first service. This is what's going to be managing just about everything. And over here in the sidebar, this PVE guide is the machine that we just installed this on over there. If I hit this little drop down, we could see some of our storage, some networking stuff. If I click directly on it, we get this sidebar right here with a whole bunch of different things. Right here under summary, you can see the specs on everything of your system. You have the shell right here, which we're going to be interacting with a lot for various commands. But the very first thing, and kind of the very first post-install thing that we do here, is go over under updates to repositories. We are going to be disabling these enterprise repositories because we don't have an active subscription. So this one right here, Enterprise Proxmox, I'm just going to click disable. And I'm going to select this Enterprise Proxmox and click disable. Now we'll get an error saying that we have no VE repositories enabled, and we're going to fix that by just clicking on add, hit OK because we don't have a paid subscription, and then going to no subscription. Click add, and now we have the proper repository to go ahead and update our system. So if I click updates right here, we can then click on refresh, hit OK. And this is essentially running a apt update command to update those repositories. And then we could go ahead and click on upgrade, and this will open up another window in which we can actually upgrade our system. So let it go ahead and do that. And there you go. When you're done, you'll get a message that says your system is up to date. Now, this is a good time to mention that everything that I'm talking about in this video is going to be over here in a written guide on my GitHub under Home Lab and Storage. You can see the post-install steps. This is what we just did. Now, one thing I do is I personally delete local-lvm and resize local storage. This is completely optional. If you have a pretty big boot drive, you're probably not going to need to do this. Right here, we have local, and you can see this only has 72 gigabytes of available free space. And then we have local-lvm. This has 151. It's only a 256 gig hard drive or a SSD. And what I want to do is I want to give all the storage to local because the primary reason I do this is I am going to have a separate kind of flash pool that I'm going to assign for VM and container storage. I'm not going to use my boot drive for this at all. If you only have one NVMe or SSD in your system, you might want to leave this alone. And I do recommend if you go over here to the guide, watch this video, which goes into more detail of the potential benefits of using LVM. Now with that, I want to get rid of it. So what I'm going to do is go under data center, and then we go under storage, and you can see local LVM right there. The content for it is disk images and containers. And then the content for local is basically everything else. ISO, container templates, backup. If you're doing this and you're not going to have additional storage, you can assign disk images and containers to it now so you could use it later. But what I'm going to do is go ahead and click on this local LVM, click remove, and click yes. So now I don't have it there, but you can see if I click over here, it's still the 72 gigabytes and not the full space that's available. And to fix that, we're going to head over here, click on PVE guide or your actual node. We're going to head over to the shell and execute a few commands. The first command is going to be lvremove dev PVE data, which is the partition area for the local LVM that we just deleted. So let's hit enter. Yes, I do want to do that. If you're following this guide after you have already done a bunch of things, don't do it. So it removed that logical volume data, and now we're going to run another command. This one is lv resize. All the free space is going to go to the dev pve root partition, which is the local right here. So I'm going to hit enter, and it has been resized successfully. Now, if I look at it, you can see we still only have 72 gigabytes, so it's not yet reflecting. And to do that, we're just going to right click, paste in this command, resize 2fs dev mapper pve root, hit enter. And now if we head over to our local storage, you could see I have the full disk now available to me within this single partition. And you can see that little thing just dropped a little. So we have a lot of space now. I primarily use this to store ISO images, container templates, things like that. So now what we're going to want to do is make sure that IOMMU is enabled. This is PCI pass-through, so you can pass through hard drives, graphics cards, so on and so forth to your virtual machines or LXC containers. And to do this, we're going to go back once again to the shell, and we're going to make just a little bit of changes to our grub configuration. So nano, our text editor, etc default. This is just the location of the grub configuration, just like that. And then right here, this line, grub command line Linux default quiet. All we're going to want to do here is just enable it by adding Intel_IOMMU equals on. Now, if you have AMD, all you want to do is switch this out for AMD, but this is an Intel machine, so I'm just going to keep that as is, output that, exit out, and now refresh that configuration. So the first command we run is update-grub, I believe. There we go. And then we're gonna do this command right here to update initramfs-u, which looking at it, I actually don't think that command's necessary, but oh well. Now what we could do is reboot our system. So let's go ahead and hit yes. And while it reboots, I will note that the guide that I have all this text on, I'll continuously update it. So if I find anything extra to do to help us out, or getting rid of like that last command, for example, all that will be updated on the GitHub. And there we go, it has rebooted. So we're going to re-log into our system, click on OK. And there's a couple commands that we can run to ensure that everything is kind of working. These two dmessage commands right here that I pulled from the official wiki. So first you run this. If you get a whole bunch of things, chances are it is working good. If you get an error or an unknown or anything like that, you're going to want to reference the wiki to figure out what's going on. And then we have this command right here, remapping. You can see remapping is enabled, so life is good. And again, right here, there's a link directly to the wiki that will go way more into detail about like GPUs and how to blacklist drivers, so on and so forth. So now, it is probably my favorite time of the day, and that is to create all of our storage. So under PVE guide, we're going to go down here to disks. I have a number of disks in the system that currently have data on it, so I'm going to go ahead and wipe them. Be sure, I don't think it'll let you, but this device right here, this has my BIOS boot, EFI partitions. This is my actual drive that the system's installed on, so don't try to wipe that disk. So I'm going to go through all my other ones. I have 2 NVMEs that I'm just going to wipe real quick. You can see it is a pretty quick process, so yes, yes. And then down here, all these 4 terabyte drives, I'm going to go through and wipe all of those out. And when you're all done, it's going to look a little something like this. You can see I have my 6 hard drives right here and my 2 Western Digital Blue 1 terabyte drives. Now these 2 drives, I'm going to put kind of as a mirror pool and set them up to store my containers and VM disks. So to do that, we're going to head on down here under ZFS. From here, we're going to go ahead and create a ZFS, and then it's going to list all of the drives. Now this one is going to be my flash pool. You can call it whatever you want. A lot of people I see call it NVMe. You could call it disks, whatever. I like to call mine flash. From there, make sure you keep add storage checked. That's a little change from last time we did this. We want to keep that, and then go ahead and check the 2 drives, or however many you plan on using for this specific use case. And then right here we have our RAID level. So we have RAID 10, RAID Z, a bunch of different RAIDs. For this one, it's only 2 disks, so I am simply going to mirror them. Do note if you're using a hardware RAID controller, this is incompatible. Do not do that. We're going to keep compression A shift as is and go ahead and click on create. So now that is creating our ZFS pool flash, which we can see there, all online, good to go. So now I'm going to create another one. So let's create ZFS, and now I'm going to select all of these remaining. These are Western Digital 4 terabyte REDs I got, and I am going to call this tank. This is bulk storage for, again, media, image backups, things like that. This I'm not going to do as a single disk, as a matter of fact. I'm going to do this as a RAID Z. 45 drives has a real nice page right here to help you kind of figure out the RAID and ZFS equivalencies. RAID Z is basically the equivalence of RAID 5, which this will protect me if I have a single disk failure. But if I have 2 disk failures, I'm screwed. But if one fails, I could switch it out and I am safe. The more secure you get with your RAID configurations, the less drives that you'll have available to you for storage, but the more that you'll have available for you to allow it to fail. So again, do some research based on your drives, how much storage you want to get the specific RAID level that you want. So with all of them selected, I have RAID Z, tank. Let's go ahead and click on create. And there we go. It is done. It's all loaded up in here. You'll notice that we have kind of inaccurate information here. We have the size, which shows the same amount of free space, which isn't really true. So real quick, I'm going to show you some ZFS commands real quick. So if we head back over to our shell, the kind of what you're seeing displayed is the Z pool list command. So you can see the size and the free space. This is showing our pools, but again, that data right there is not really accurate in the actual like available usable space that we have. Now, if we run the command ZFS list, this will actually show us the amount of available storage that we have to us with the RAID configurations. So instead of basically 22 terabytes, you could see I have 17 terabytes actually available to me and usable. And now, since we basically have everything ready to go, we could create our very first container. And this container is kind of like my main media server container, has most of the data on my server in it. I end up using this for like all the server applications, Jellyfin, music, ebooks, all that kind of stuff. And you can obviously set this up and configure it how you want, but this is just how I do it. So first we're going to go over to our local storage, and we are going to go down to container templates and click on templates, because we're going to get a little template to spin up an Ubuntu container. Again, use the distro that you prefer the most, or that you have the most familiarity actually playing around with. If you have no familiarity, Ubuntu is a good place to start. I am going to go with the 22.04 version. Seems to be better supported on Proxmox at the moment. So I'm going to select that and click on download. And that will just take it a little bit of time. And now you can see that the task is okay. So I'm going to close that out. And real quick, one thing I almost forgot to do is go under data center storage. I just want to make sure that this is available. So tank is disk image containers, beautiful. So now we could go ahead and create our container. So I'm going to go up here and click create container. The node, which is our actual physical machine, is the PVE guide. I'm going to keep the container ID at 100. You could change that if you need be. One thing I like to do is match the container IDs to the end of the IP address on my local system. It's just kind of an organizational thing that I started doing. For the host name, you could call it whatever you want. This could be media. Before I called this Vault. On my actual machine, I have this called Serve R because it runs all of that kind of stuff. But just for simplicity in this guide, I'm going to call it Media. We're going to keep it as unprivileged, mostly for security reasons. Keep nesting checked, and we're going to give it a password, just like that. And then we could continue. And storage, we uploaded it to local, and we're going to select the Ubuntu 22.04 and then go next. Now here under disk, we could see we have all of it available. Flash is where I'm going to be storing the disk because it's the NVMe drives. And for size, I do end up putting quite a bit into this first one. Not the actual media files themselves, but like my Plex or Jellyfin configurations. Depending on how big of a media library you have, your configuration folder for that can get pretty large with like a cover art and all those kind of things. So 64 gigs seems to be kind of a safe spot, and you could always expand the storage in the future if you need to. So let's go next. CPU, I'm going to up this to 4 cores. Again, the actual specs of the system depends solely on what you're doing. For the RAM, I'm going to give it 4096, roughly 4 gigs of RAM, and I'll up this just a little bit, the swap memory, to about 1 gig, and then we'll go next. And here we are going to want to do some changes. If you just keep it as is, hit next, it's not going to connect to the internet because we haven't given it an IP address. If you want your actual router or your network stack to manage this, you could go DHCP and assign it through there. But I like to go static and just assign it right here as a static IP. For me, it's 10.0.0.100, but that's what I would normally do. I'm actually have this in use right now. So I'll just go like 33-24. And gateway is going to be your router. So 10.0.0.1. I'm not going to give it a v6 IP for now. And we could go next. DNS, keep all that as is. And everything looks good. So we can confirm it. So let's hit finish. And then it's going to extract it and set everything up for us. And there we go. We now have it. If we go over here, media, resources, we could see it is on the flash pool with a sub volume 100, disk 0, 64 gigs. Now, I'm going to want to add some more storage to this, specifically from this tank right here. So to do that, what I'm going to do is I'm going to click add, and I'm going to add a new mount point. Here, mount point 0 is fine. This is going to be using the tank pool that we created. And this, I'm going to give it a ton of space because we're going to be putting media and stuff on here. So I think I had 17 terabytes available. So for now, let's go ahead and give it 8,000 gigabytes. And I personally like to mount this in the root data directory. It just makes everything easier for like Docker configurations, kind of my own personal organization and management. And for now, I'm not going to back that up. I'm going to set that up in a future video. So do subscribe for that. And let's click on create. So there we go. We now have 8,000 gigabytes available in the data mount directly on this container. And something else I like to do is add a separate mount point for Docker. So let's go mount point. This one I'm going to keep as flash because it's just small configuration files. I want them quickly accessible. And this doesn't usually get too big, so 32 gigs will be fine. And I will mount this directly to Docker. Uncheck backup for now, and then click on create. So now you could see I have my root disk and I have a separate mount point for the data directory with 8,000 gigs and another directory on root Docker with 32 gigs of available space. So now I could just simply start up this container and actually make sure those mounts are there and do some initial setup stuff. So if I head over to the console, we can log in as root using that password we created when we set up the container, and boom, we're in. First thing that we always do, no matter what, is just do a sudo apt update, let that run. We do have a number of packages to upgrade, so let's apt upgrade those. Whole bunch of them, yes. And it's just about done. We don't need this so big. Let's make that a little smaller so we have more room in our terminal here. And there we go. And if I ls into root, we could see we also have this data and Docker mount. Now, doing everything at root generally isn't the best idea, so I am going to add a new user, and that user is going to be Brandon. You don't have to call it Brandon, call it whatever you like. Give that user a password, like that. These aren't really important because we don't have other people on our system. Information is indeed correct, and boom. So now let's add user Brandon to the sudo group so I can execute root commands with that user. And there we go. So now let's simply switch our user over to Brandon. And now I am in fact Brandon. And one thing we're going to want to do is switch up some permissions. So if I cd into that data directory, for example, and I try to touch, which is just creating a file, let's say test.txt, it is going to give me a permission denied. But this user, I want to be the owner of both the data and Docker mount points on this system. So over here, I have some commands. So we have a sudo hmod r data and the owner. So I'm going to actually change the owner first. So if I drop this in, this is a sudo chown recursive. So it's going to affect the folder and everything in it to the user Brandon and the group Brandon. When you create a user, it automatically creates a group with the same name that you are assigned to, and /data. So if I hit enter, type in my password, and then I'm going to do the same thing with the Docker mount that we created. And now I should be able to go ahead and touch in there now. If I ls, we can see we have the test.txt. So now we've done a lot. We've created our storage, did all the post install stuff for Proxmox, created our first container with the user with the mount points. And now I want to be able to access these mount points within my entire home network as network shares. Now, in our last video, we used Cockpit to go ahead and do this with a web interface and all that. That's still an option if you want to do it that way, but I've actually found it a little bit easier just to do this directly on the system with Samba or Samba. Again, I have all the steps here, so this is a lot of terminal work. I have my configuration file right here. You're going to want to make edits depending on your username and all that, but first things first, we're going to want to go ahead and install it. So apt install Samba. This is going to install our Windows Samba server. Yes, install everything. So once we have all this set up, you'll be able to see, like in your, if you're on Windows and Network Discovery, or Mac under Network, you'll be able to see these actual folders as shares and upload files and interact with them that way. So now with it installed, we can change directory to Etsy and Samba. Within here, you could see we have the initial configuration, a couple other things. If I just look at the initial configuration, it's going to have a lot of kind of filler stuff with printers and a bunch of comments on how things work. We're going to want to keep this one to reference it if we ever need to, and just in case if anything goes wrong, we could revert back to the default configuration. Now to back up this file, I'm just going to simply move it, the SMB configuration, and I'm going to move this to smbconf.old or .back, whatever you want, and permission denied. So you're going to want to do this as sudo. So sudo. Boop. Now if I ls, you can see it now has the .old tag. So we're just going to want to nano to smb.conf and create a new configuration file. So hit enter. Oh, exit out of there. Do this with sudo. I keep forgetting that, my bad. And then right here, I have my entire configuration. I'm just going to give this a copy and drop it in and kind of explain everything. So if I paste this in and scroll on up, first we have our global settings. So the server string, I have it as serv_r, but I can actually just change this to media. I like to kind of match that to the actual container host name. Workgroup is the default. You can change that if you'd like to. Security I have set to user, so it's going to require a username password to access it. Guest is going to be bad user, and I'll link to configurations so you could set up like group folders or make it so guests can access and download specific folders. But for now, this is my home network. Nobody in my home really accesses these network shares, so I don't really have it set up to be accessible unless if you log into the account. We have a name resolve order with host and bcast. This right here is kind of a little security thing. I do hosts allow with 10.0.0.0. So anybody using a local IP address similar to my local IP address scheme will be able to access this. But if you come in somehow from an external source, from an external IP address, you're not going to be able to access this. And host deny, basically any other public domain or IP address is going to be denied. And then below the global settings, we have two different network shares, one for data and one for Docker. This simply is going to be under the path data. It's going to force the user group to be Brandon. Create mask, this is just permissions. So when a file is created, it's going to automatically have these permissions. So the user group will have full read, write, and execute. And then anybody else, I believe, will just have read. Same with create. Directory mask is very similar. It's browsable, writable, read only is no, and I set guest OK to no. And then the Docker configuration is exactly the same. So if I output that, boop, head over here to my little docs. We're going to want to set the password. So if I drop this in, we're going to go with the user Brandon and then set our SMB password, which is the password used to actually connect to it. From other machines, we've added the user Brandon with the password. And then from there, we're going to want to enable and restart the services. So first, ensure that the SMBD service is enabled, and then enable the NMBD. And then we are going to restart both of these. So restart, and then restart, just like that. And that one thing you could do, if you ever run into any issues, you can enable the Samba through the firewall on your system, but I might not need to do that, so I'll just check first. So on macOS here, if I open up my file browser and then I go over to network, I will see media right there. That's the one we just created. If I open it up, and then right now I'm guest actually, so if I show you an example, if I try to open up data, it's going to throw an error. I didn't connect as a certain user. So we can head on back to it real quick. Open up media. This time I'm going to connect as Brandon, type in the password, connect, open up data, and then we can see that test.txt file we created earlier. And now if I wanted to, just as an example, if I open this up and I say, hello, writing this on Mac OS, save that out, close it, say okay. Did it actually save? Macs are so weird. Yeah, it did save. Okay, good. So now if I cd into our data directory, ls, you can see it's still there. But if I preview what is in that file, we could see, hello, writing this from Mac OS. Beautiful, it's working. And real quick, this is my main server. I'm going to launch a Windows VM real quick, just so I could show you how to enable discovery. So let's log into Windows here. And then if I go over here and I open up the File Explorer, and then I head over to Network, you can see the only thing that I could see is Servar. It's my other share. So it's not auto-discovering the one that I want it to auto-discover. So if I head back over here, we're going to install a package. We are going to install the package wsdd. This is the Discovery Windows software. So if I hit enter, it's going to go ahead and run that installer. And then if I jump back over to our Windows machine, you can see it pop up right there, ready to go. If I double click on it, you may get an error at first saying that it's not able to access it, and that's because we never logged into it. So to kind of get around that, if I navigate it to it manually real quick, so media, like that, hit enter, then it's going to ask me for my network credentials. So if I go ahead and log in, remember those credentials, and then okay, we're now into it. So if I go back to network, I double click on media, I can now access it. If we jump into data, we could see text, and now sadly, I'm now on Windows. Save that out. And then if we head over here and then cat that again, you could see sadly, I'm now on Windows. And this is only a gigabit network, so if I just kind of copied something, copy, it's not going to move too incredibly fast, but if I go over here to media, data, drop this on in here, paste, yes, we could see it's moving at a normal 1 gig kind of rate, or a gigabit kind of rate. I really need to upgrade my server, my network stack eventually, and then it is done. So now you can see it in the folder there. If we head back over here and ls, we could see we now have the Windows 11 IoT Enterprise version right there ready to go. So that is my part 1 to this series of videos. I already have an existing part 2, part 3, part 4, a couple different parts. I'll also be remaking part 2 in this similar format. If you follow part 2 right now after this video before I remake it, just keep everything within this single media container. Don't make a whole bunch of them and connect the virtual drives. And if you do it that way, you'll generally have a pretty good time. Again, big thank you to everybody who's contributed, submitted issues, done commits to our GitHub Home Lab repository. It has been incredibly helpful, and the more I keep that up to date and keep this documentation going, the better of an experience the people who utilize it will have. So if you have any tips, tricks, or anything like that, leave them in the comments down below, or put an issue up on that GitHub and I'll go ahead and test it out and amend the documentation. And with all that, don't forget to subscribe for upcoming videos and all that fun stuff. Have a beautiful day and goodbye.